All right, guys, cool. So we got a lot of big ideas to go through today. We got about 2 hours solid to get through. I think we can get through one chapter and one appendix. Originally, I was deluding myself thinking we would finish the book in this session. I looked at this chapter. We're about to read chapter 10, which is called, what's it called? Isochronicity, Least Action, and the Parmenides Paradox. We're not going to get through this book. I think most of our attention is going to be on this chapter. And before we read this chapter, I'd like to read one appendix, which is Appendix 10, which is going to introduce some key concepts we need to have in our minds as we flesh through this. For those who are watching online, if you've missed any of the readings, you can watch. Most of them have been recorded and are on the Rising Tide Foundation YouTube channel, including a lot of the discussion. The book itself is available on Kindle for $10, or available in this, and the link is going to be in the description box. So last week, I know we touched on some elements of false versus real growth of an economy, because the whole thing that we're looking into in Defense of Common Sense, the thing that we're chasing is how do you measure real economic growth and forecast it in a way which is in alignment with the laws of the universe. And obviously, part of the problem is that economic growth, unlike the growth of ecosystems, is defined by free will and human creative thought. So when you have a new discovery that then translates into a new invention or technology, that gives you an edge to sustain more people at a higher quality of life, and that's wonderful. Except, how do you forecast what a creative leap is going to be, which is outside of the deductive, inductive systems that you live in at the moment that you're making the forecast? So no linear extrapolation of any present trend is going to work at forecasting a creative leap. It doesn't work that way. People who don't realize that believe that artificial intelligence is going to replace human thought at some point, because they're just looking at this speed and complexity of calculations and assuming that that's all the human mind does. Whereas in reality, we're a creature endowed with capabilities that are far different or beyond simply the, those linear motions of logic. So we looked at the U.S. economy as a case study, the different ways that gross domestic product has been fabricated. The data has been fabricated to give off false images of progress, whereas in reality, what LaRouche was stating is that there has been zero progress, zero growth since the mid to late 1960s, and he was writing this in 1991. Any growth that's being registered is purely fictitious capital. It's not tied to the growth of the real economy, and in fact, when you look at the real economy, the productive base has been hollowed out, the ability to sustain populations has been destroyed, and the potential population has been undermined and lowered successively every year since we chose to become a post-industrial consumer society. And that's measurable in a relativistic way. So one of the challenges that were thrown out was, can anybody, and this was something we talked about last week, can we think of any examples of times where the attempt was made to increase productivity of society, whereas when we did so, we actually undermined that society's ability to sustain itself in the future? I think, Quan just reminded me that we had the example of the British example under Isaac Newton's control as the warden of the Mint of the Bank of England, where the need to increase productivity was put forth, and his solution wasn't to go for a better technology or invest in R&D or anything like that. He just had people work faster and speed up the machines, which resulted in tons of fingers, getting lost, cut off, injuries galore. Not really a true productivity. And so, Eureka, in our discussion before we began this, you said you might have a thought or two of another case study, or maybe more than one case study that you'd like to share. So what did you come up with?
I wanted to bring up the current influential medical journals. For example, the New England Journal of Medicine and the Lancet today are the two most influential resource medical journals. But at the same time, and this is what kind of determines the situation that we're in right now, these two very influential medical journals, but they are completely funded by the pharmaceutical companies. Would that be an example that we could use where everything is going in this direction where it's supposed to, in that field, create some kind of growth? But because it's so narrow and
yeah, I think I see how you're thinking about that. Yeah, I think you're touching on something there, because there's definitely what many would say would be an increase in scientific productivity in medical science and innovation because of all the money being poured in, and there's hundreds of billions of dollars being poured into increasing advances in medical science. But in reality, when you look at how perverse and unscientific the actual epistemology is underlying that scientific practice, as well as the production of ideas and medicines and practices, it often undermines your overall health of the society, and in fact, it can reduce it quite a bit. So yeah, I think that's a good fictitious progress that you just illustrated there. I think that's not bad. Anybody else have any other thoughts or other examples?
I don't know if it's a good example, but the F-35 is a true disaster because with all the money poured on that airplane, and it's not even capable to perform better than the F-15, for example, even if I admit that my example is not very inspirational.
No, I think you're right. I mean, especially when you look at like how Russia has been putting in their money in their military budget into R&D, which has produced planes that have like these incredible, they could like rotate 360 degrees. So they've been going for real qualitative breakthroughs in their in their military technologies, whereas we've just poured in tons and tons of money, way more than they have, in tech that doesn't do anything qualitatively differently than planes of decades ago, and it's a disaster. So yeah, that's good too. Anyone else? We have time for one more before we kick in for. I'm going to say a few words of introduction, like I said, to just sort of set the tone for some of the ideas we're going to look at, with a few videos and images. Do we want to try, for example?
Yeah, one last.
Okay.
The education system. Okay, you pay a lot of money for classes that are not worth much, except maybe in certain professions like medicine, pharmacy, engineering. Those are the last of the Mohicans in the education system.
All right. I would not disagree. Okay. So here, let me just do, I'm going to do a quick little screen share. I put together 7 slides with some questions and images. So I'm just going to share that with you guys. So just because, like I said, this particular chapter is so dense and it will be easy to get discouraged, to fall off track, I pulled together these questions just to hold them in mind the whole time that we're reading through this. So the questions, number 1, I think these 3 are the most important, but there are others, obviously. But how do you express scientific and technological growth in a system? The other question to hold in mind is, how can the creative change transforming a system A to system B be made intelligible? Number three, how do these changes result in the increase of the potential population density of a system? The key thing we're going on when studying physical economy, and that's really the subject of In Defense of Common Sense, is what is the science, the true science of economy, since everyone's talking about the scientific management of society, but a lot of those people talking about that really just want a scientific dictatorship, which is really out of alignment with the nature of the species that they're trying to understand or manipulate. Not even understand, just manipulate. So when we're talking about that, part of the scientific reality of the human experience is that our population growth grows in ways which we don't find in other species of the biosphere. This is just two, or actually one example of something which we're often shown in primary school and high school, the population growth, which we see spiking after the Renaissance period around the world, especially in the West. The Florentine Golden Renaissance is a period where we had a massive geometric increase of populations, both in quantity but also in quality of life. Longevity increased massively. We're often shown these things in school and in our current society, though, as ways that try to convince us that we are a parasite or a cancer in nature. And there's many environmentalists, including some Canadian celebrity environmentalists like David Suzuki, who have used this chart to try to say that the only thing which reproduces this way are cancers, and that's what we are. And you know what you do as when you have a cancer. If you're a doctor, you have to do surgery. So Lyndon LaRouche's point throughout his works over 50 years has been that this is actually not an unnatural cancerous thing, but this is a very natural and good thing, but it's only good under certain conditions morally that have to be met. And we are going to go through what happens here when they are not met in some cases, and also what ways are encouraged for us to think about the process as a whole. What is the nature of the system, both of the biosphere, but especially of the human economy? And we have a choice when we're looking at defining the space-time of the system and what is the nature of man. We have to ask, we're told we're allowed to ask one of three hypotheses. Either it is a random system, it's chaotic, it's basically just governed by irrationality and random changes, which somehow often create apparent order, but it's not really defined by any principles. Or B, that it's a static system, which is actually not true. Anything static is ultimately decaying, because there's a certain idea that there's a fixed amount of energy in the system, and that every time you have more people or the people live longer, that energy sustaining the system is drawing down, resulting in a heat death of the system. That's another option. Or the third one, which is the one we're operating on here, is that it's a self-perfecting system. It's a self-organizing, improving system capable of unbounded self-perfectibility. So the first one is something we've been living under now for decades, since really the 1970s, floating of the US dollar onto the floating exchange rates and the creation of an unbounded speculative money first worshiping system, which is really based on, whatever you see from the Wolf of Wall Street, right? That principle of gambling and assuming that business cycles might somehow permeate the desire of every individual alpha within the system who has the money to gamble to make cash, and thus somehow innovation and creativity happens. That's one option. That's proving itself to not work. So now we have increasingly our ideas coming out of certain crowds in Europe and Davos, saying that no, this has proven itself. The free-for-all of the last 45 years has proven itself to be dysfunctional. That's not the right way to organize society. We need, like I said, the scientific management, and they're saying Malthus had it right. So the principle of population is something we can calculate scientifically as something which grows, and it always grows faster than the food production and the other resources that are needed to sustain that people. So such that you will always get a crisis in overpopulation, and thus the ruling elite must always regulate the population in accommodation for the scarcity of nature. That's obviously, we have A and we have B options right there. The third one is the one we're going with, which is the idea that the human creative thought has the power to supersede those limits to our existence. There was one more. Okay, so in thinking about the nature of, what is the nature of the language that we have to think about using when we're defining the human system, there was an idea of, oh, and I lost my slide, okay, I had an image pulled out that I lost. So we have an idea that he's been raising in several chapters of Euclidean geometry versus physical geometry. Euclidean geometry being something like you can imagine an imaginary sphere as like a mathematical artifact in nature. That's something that's imaginable. But a sphere that's a mathematical entity is really something of the mind. It's not something which has physical, it's not something that has physical existences. Whereas the type of geometry which we're talking about, since the universe, you know, our reality, our evolution happened on a globe around a sun in a galaxy with certain fields, with a certain shape to that whole space-time. The type of sphere that you would find with a bubble would be very different. So a bubble is a sphere, but it's a sphere that has certain characteristics because it's constrained and bounded by certain physical principles. What I have and what I want to do next is just show something to do. It's a little 1-minute video. Okay, so this is a short little video of the types of geometries we get with bubbles, soap bubbles, and just soap in general. So you can imagine how each of the surfaces being affected right now could be expressed as a two-dimensional Euclidean flat surface. But if we give that surface tension, we as you find with a soap spread, there's certain shapes that will tend to occur as you push it, as we see with this needle, right? Certain cones are forming, as we just saw with that needle. There's a certain surface tension which is being obeyed, which has been called the isoperimetric principle, the tendency of the surface to express itself that tries to minimize its surface area. So there's physical forces, and how here you have a needle pulling on it, so you get like an inverse negative curvature with a cone, and then a cone being created out of pushing on it. And here's another pulling process, and with the distance that you're getting, you're getting different types of physical curves. And these look on the surface like the sorts of curves you get from like an ellipse or a circular cross section from a circle, but they're not. These are different sorts of curves. They're not actually parts of ellipses, or even parabolas or parts of circles. We've been introduced to the name of Bernard Riemann a lot as somebody who created a geometry, an anti-Euclidean geometry, which LaRouche has been saying, if you want to understand the statecraft of political economy properly, you have to have a sense of this language, because Riemann was looking, again, just like we were, at physical geometries, at physical curves, and what is the nature of the higher reality that shapes the reality or the mathematical language which many people think they're seeing when they're looking at a flat surface. So just like this, we have a Cartesian grid, and this is a quick little introduction at the way of thinking that Riemannian surfaces give us. And we'll be able to see quickly how this is a qualitatively higher way of thinking. How everything in the two-dimensional world that Euclid talks about can actually be seen as a projection from a higher dimension. So here's it doesn't have the sound, unfortunately. Okay, so we have our little grid color coded, moving around, getting bigger and getting smaller, right? What's actually happening here? From a purely two-dimensional standpoint, it seems straightforward. Okay. For those who saw the video on prime numbers and Riemann's hypothesis, they'll be familiar with some of these images so far. Now the animation is going to slowly change, and we're going to see how this is being shaped by something higher. There we go. Now we're getting into a dimension we might have forgotten exists. So now we're realizing that what we were seeing was just a projection of an image on the surface of a sphere, with a light source projecting down and casting the sort of shadow on the two-dimensional plane surface. And so what we saw this thing getting bigger and getting smaller and bouncing around. Now we see what was causing that visual effect. It wasn't what we thought it was. Now they're rotating the sphere, right? And so we're seeing how that same image is being created by a very different process than what is intuitive. And we get the same. And these are the sorts of things on the graph paper that you tend to come across if you're working on Gauss's complex domain as well, and imaginary numbers, the square root of negative numbers.
They chose the music to be by Robert Schumann as well.
I know, it was gorgeous. I'm just having trouble with my sound right now, but I'll make sure everybody gets these and they can rewatch these things as they see fit.
I'm sure Schumann will have some sort of understanding of these ideas too.
And I'm not going to say much more. I'm just going to describe, because the other two videos you're required to have, you did need to have sound, and I don't have that. But basically, the other one I want to show, and I'll email these out, like I said, is on sonoluminescence, which is a phenomenon whereby when you have a bubble in water, well, basically, when you create a bubble in water that didn't have bubbles, you can do that by just introducing sound waves at certain vibrations that vibrate the water molecules so intensely that hydrogen starts to break off and forms bubbles. And because the intensity of the vibrations of the sound waves are of such a quality, if it's intense enough, the gas within the bubble space will begin to collapse in on itself. And what they've been able to create in labs, and they've seen this in nature, and certain animals even do this, is that collapse will create heating in the center of that bubble, such that a very small burst of light will occur. And they call this stars and jars, for those who have made these things in laboratories in recent years, because the heat emitted by these small specks of bright light are of the magnitude that we find in the coronas of suns. It just happens so quickly that it doesn't destroy the water in the containment units. So that's something which happens at different types of frequencies. Microwave frequencies are also a factor in this. And what we have in nature are frequencies interacting with frequencies of different types, which also interact with matter, which itself is made up of different types of phenomenon that are not simply matter as such. We're made of electrons, nuclei, protons, all sorts of things that we have yet to properly understand. So how these different organizing principles interact with each other, creating certain phenomena in space-time that we can sort of try to describe, that's an important theme that will be played upon very deeply in the chapter we're going to read today. The last one is a video which features, it doesn't matter, I'll just send it out. So for today, let's just start with reading the appendix 10. Okay, so this is called scientific tuning. Oh wait, this is not what I wanted, is it? Hold on.
It's Verdi's tuning.
Yeah, okay, this is actually what I want. I want to introduce this idea into people's minds. And a lot more has been written on this. Actually, Jonathan Tenenbaum, who gave us a wonderful lecture a few weeks ago, is the author, I think, of this particular appendix. So, Nick, why don't you go ahead and read this part?
At a Schiller Institute conference on April 9th, 1988, on the above theme, Dr. Jonathan Tenenbaum explained why middle C equals 256 Hertz is the only acceptable tuning in music, which might not be arbitrarily raised or lowered without negative consequences. In this, Tenenbaum drew upon a working group of physicists, biologists, musicians, and instrument builders who had pursued the urgings and the hypotheses of Lyndon LaRouche. What follows is a selected summary of this presentation. The human voice, the fundamental musical instrument, is a living process. Leonardo da Vinci and Luca Pacioli proved that all living processes are characterized by a special geometry whose most visible manifestation is the morphological proportion of the golden section. Since music is a product of the human voice and the human spirit, it must be lawfully coherent with the golden section. And it is. The classical well-tempered system is based upon the golden section. The American mathematician Carol White showed this with respect to two sequences of notes whose musical significance ought to be clear to every musician. C, E flat, G, C, and C, E, F sharp, G. In the first sequence, the different frequencies of successive notes form a self-similar array in relation to the golden section. The different frequencies of the second sequence decrease according to the golden section. Where now lies the particular meaning of the frequency middle C equals 256 Hertz as the true value of musical tuning. Kepler derived the musical intervals from the division of a circle, so to speak, a circular string, by an inscribed regular polygon. Thus,
Okay, so just quickly, what he has here is a descriptive grid of an octave being created by having a circle that you fold in two. So imagine that the circle represents a string that's been turned in on itself. So you have a string that vibrates, but you took the two ends of the string and you pull them together, making a circle. Now, he just made the point that the relation of 1 to 2, half to the whole, can be created by simply folding that circle. A fifth could be created as a triangle. So a fifth on the piano or on the violin or guitar can be created if you construct a triangle within that circle, which then divides the edge of the circle 3 times, creating the ratio of 2 to 3. So 2 parts of the circle to the whole circle creates a sound relationship, which is a fifth. Then you have the fourth, which is when you put a square inside the circle, which gives you the 3/4, right? Because you divided the circle's perimeter by 4. And a major third is a pentagon, which is the golden section. So you have to then figure out how do you construct the pentagon within the circle. And you now have the 4/5 relationship, which again sounds, this is the origin that Kepler discovered of the major third. And it gets more complex in Kepler's writing. This is descriptive. One can actually take a compass and build this themselves, which is why we should all have compasses that are of good quality and just do this ourselves. And ideally, test them out on a guitar string or something like that to verify that what he's saying is true. or as Quan probably has a guqin, a guqin.
Chin, yes, chin.
Okay. Sorry, Nick. Yeah, you can go for it now.
Wait. Thus, going one octave down corresponds to doubling the length of the string. A series of such steps by octave, an array of powers of 2, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, so on and so forth until 2 to the power of n. The frequency middle, C equals 256, corresponds to the circular action, rotation, of 256 rotations per second, or one rotation in 1/256th of a second. Now let us take the time for the Earth to rotate on its axis. We divide this by 24, 2 times 3 times 4, and get 1 hour. Divide by 60, 2 times 3 times 4 times 5, and get 1 minute. This again divided by 60 gives us 1 second. These seconds we divide now by 256, 2 times 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 2. Now we can easily calculate that the Earth's rotation corresponds to a G that lies precisely 24 octaves below middle C equals 256 Hertz. Scientific tuning is thus anchored in the solar system. The A equals 440 Hertz, on the contrary, has a purely arbitrary value, which absolutely cannot be justified in physical geometry.
Yeah, and then for those listening, we have the referenced figure 14, which features a small image of I guess you could think of it as a large string with several octaves, going from frequency 0 to 32, which is the first octave, where C is 32 hertz, and then you double that to get a higher octave, C at 64 hertz, and then you double that 64 to get C at 120. C 128, and then you double that to the next octave up to get C 256, and then he shows us the relations that were described from C to G to the higher C, and then from that higher C at 512 to E to F sharp to G, which gives us proportions which, if we explore, will bump us into the golden section, the pentagon construction in various ways. Yeah, and for those who may not be aware, current musical standards, primarily in the West, are mostly, when we build instruments and things like that, they're mostly built according to a certain universal standard, which is A440, which, as Jonathan Tenenbaum is pointing out in this little write-up, is completely arbitrary, has no physical standards to be what it is, right? To be called a standard. It comes out of thin air.
It just sounds all right.
Yeah, it rolls
That's
off.
it. Yeah, pretty much that's it. That's why that's how even like artists today can have such a bad technical standard in music.
Mm-hmm.
It starts right there, like with all of that stuff.
Right.
It's the same with the abstraction of like aesthetics in ballet and stuff. The deconstruction method, like to take ballet and then deconstruct it to the point that it doesn't look anything like what it was. Because that's the way that they think of creation, that you just from what you have, and that's new. When it's not at all, actually, it's ugly and painful. But yeah, there's just a little bit of my frustrations coming out. Sorry.
I can see that.
Just have to put that in. But there are recordings of at this pitch, and Furtwängler did some. Wilhelm Furtwängler, the conductor.
Yeah, that's right.
And Verdi insisted on this.
On the C256 tuning, yes.
Yeah.
That's right.
Shall I read on?
If you'd like.
Today, we might still add some essential points to this. For our universe can only be imperfectly described using circular action. At the beginning of the 19th century, Carl Friedrich Gauss introduced, instead of circular action, spiral-formed or conic action into synthetic geometry. Spiral-formed action combines the isoperimetric principle of the circle with the principle of self-similar growth, such as expressed, among other things, by the golden section.
And we're going to look at it. Oh, not yet. Okay.
In our figure 15a, the axis of the cone presents the frequency. During the frequency shift of 1 octave, the spiral completes 1 rotation upon the surface of the cone, e.g. from C equals 256 to C equals 512. 1 octave, thus, corresponds to 1 complete turn of 360 degrees of the spiral upon the cone.
Yeah, I'm just going to look at I think that's a good place for the image.
Yeah.
So people have to use their imagination. Can they see that cone rotating from the C256 starting point? And can you see the radius of that circle rotating as it grows, becoming C512?
Mm-hmm.
Yeah, you can all see that rotation creating a certain spiral on the surface of that cone.
Yeah.
360 degrees, right? Back to the start.
So C512 would be an octave above C256.
Yeah, it's like doubling the length of the chord, or having
Right.
the length of the chord in some cases.
Okay.
More like having the length of the chord, yeah.
And right, yeah. Okay.
Good. And then along that, you'd have those divisions. So the the circle at, let's say we have 12 notes on that scale between C and C. Then we have the F sharp at 362 at that one moment, but there is you could express all of them as places where the radius is rotating, right, at a constant rate and touching each of the sides of the cone. So let's go back to that. Whoa, what just happened there? Oh no, what happened is I hit the triangle button. Does anybody remember what?
What?
Oh no. Oh, did I just get
that's it. Just one more.
Oh wow, I got lucky.
Yeah, go forward.
That's like winning the lottery.
That's it, one more, and then I think that's it.
Is this one? Yeah, it's this one.
Yeah.
Okay.
Yeah, somehow it's changed now because
I don't get it, yeah.
part on the left was on the right before. But yeah, well, funny.
The book is being edited as we speak by Emma.
Right. Taking words away. No, it's right. Okay, so where was I?
Figure 15b.
Figure 15b shows the projection of the cone onto the flat plane below. The surface of the cone is divided into 12 parts. Each slice of the circle represents a bel canto, half tone. A 30-degree turn around the spiral corresponds to a half-tone interval. The radial lines, measured out from the midpoint, correspond precisely to the frequencies of the scale of the even-tempered system. The fifth corresponds to a turn of 7/12 of the circle. The minor third corresponds to a right angle.
Okay, I guess we'll have to look at that.
Yeah.
Okay, so that's the projection onto the flat plane below the cone, right? Basically what it described, so we can get those different lengths that if they were, let's say, chords, strings, they would pluck different frequencies that would be in accord with the C, B, B flat, A, all the way through the octave, or through the scales. Whoa. Oh, that's so weird. Okay.
Right. So just to clarify, like he says C equal, like, you know, because to picture it, C equals 256 or C equals 512 is the same. It's just he's saying that the middle key of the piano, like the middle C, should be tuned to C equals 256. Yeah.
Mm-hmm. Yeah.
Okay.
And then you're right. It is important.
Yeah. Because I'm just thinking about, like, I'm just asking myself, like, why decide that it's 256? Like, why could the middle key not be 512?
Jerry, you have a thought on that?
Why is it that is it because it's the middle of the cone, or?
No, it's the middle C on the piano. They call middle C.
Yeah.
And you're just saying, Nick, why wouldn't the middle C be 512? Is what you're
Yeah.
asking?
Why is it that 256 is the perfect pitch if 512 is in correspondence to that?
I think that has to do with the human singing voice,
Right.
I believe.
Okay.
I'm trying to remember what I've read from the old tuning and registration book, but it has to do as well with the human singing voice in the first register, I believe. But
Yeah. There's a beautiful diagram at figure 17 for that.
Okay. Cool.
Cool.
Then we'll wait till we get there. So,
Okay.
right. It is important that the note F sharp lies after each half turn of the spiral starting from C. This interval, C to F sharp, the minor fifth of C, is known as the Devil's interval. It lies precisely at the geometric mean of the spiral formed action between C equals 256 and C equals 512 hertz.
Okay, so that's all right. So we have, again, looking at figure 15A. We've looked at figure 15B. Right, and each of the 12 tones is divided by 30 degrees accordingly. That makes sense. All right. You want to keep reading?
Yep. Other synthetic geometric constructions bring to light even more wonderful things. For example, let us cut the cone diagonally between the two circles at the frequencies of C equals 256 and C equals 512. Figure 16a.
We'll look at both figures together. Just finish
The result is an ellipse. Now we project this ellipse onto the plane below and obtain precisely the frequency relations between the most important dividing points of the octave. Let us imagine that the ellipse were a planetary orbit with the sun at the left focus.
Okay. All right. So this is where it gets really, really interesting. So we're all used to the common ways of looking at models of the solar system.
Mm-hmm.
This is much more useful to
Mm-hmm.
think of these different ellipses, because each planetary ellipse has a different eccentricity. They're not all the same ellipses, but they're all ellipses, meaning they have two foci, one foci being the sun. The most satisfying way I've ever seen is what's being described for us right here, where you have your cone, and then you have a projection from the cone onto that surface below. And anytime you make a cut diagonally across the cone, as we see on the right-hand side, you have an ellipse with two foci. One foci would be the base of the cone.
Mm-hmm.
And he cited 16b. Did he already cite 16b? No, he didn't do that yet.
Yeah, no, he did.
He did. Okay.
Oh, I think
Right.
so.
And so this would be, if you were thinking about this as a planet, you would have C prime or C prime and C double prime. as the aphelion and perihelial distances. So the closest and fastest distance of the planet from the sun, and the furthest and slowest distance on the other extreme, with the F and F sharp being expressed by the, I believe this is the arithmetic and the geometric distance on the cone.
Yeah.
Which is something that has to be explored a little bit more constructively, but just to say, very interesting.
So that's why, you know, we have certain periods where we're closer to Mars and stuff, because the orbits are not equal.
Mm-hmm.
Unlike, yeah, otherwise it'd just be the same distance all the time, wouldn't it?
Yep, wouldn't matter when we shoot off to Mars.
So then the sun, you know.
What's that?
Well, like, yeah. Then can you call the sun the center? Because it's not.
No, it's just a foci.
Yeah, it's just okay.
Yeah. And over time, you know, these orbits are also changing as well, right? You have like sort of a breathing pulsation over time of the size of the ellipses.
So that's where they completely screw us in schools, because they show us these maps of like perfect circles around the sun, but it's like nothing could be further from the truth, actually.
Nope. Okay, I think we were here, right? Other synthetic geometry. Was it here?
Yep. No, I read that.
You read this?
Yeah.
Okay, sorry. Then we're here.
Hence, in figure 16b, we call the shorter segment of the major axis perihelion, closest distance to the sun, and the longer segment aphelion, greatest distance from the sun. C equals 256 corresponds to the perihelion of the ellipse. C equals 512 corresponds to the aphelion of the ellipse. F corresponds to the perpendicular at the focus. F sharp corresponds to the semi-minor axis, and G corresponds to the semi-major axis.
We're going.
At the same time, F, F sharp, and G correspond to, respectively, the harmonic, the geometric, and the arithmetic means of a turn around the spiral. These three means form the foundation of classical Greek architecture, of perspective, and of music. The same notes, F, F sharp, and G, mark the fundamental lawful division of the C major scale. It consists of the two congruent tetrachords, C, D, E, F, and G, A, B, C. The dividing note is F sharp. Precisely at the F sharp is where the register shift of the soprano takes place. The first tetrachord, C, D, E, F, is sung in the first register, while G, A, B, C is sung in the second. The register shift hence divides the scale precisely at the geometric meaning, or after a half turn of the spiral upon the cone. The same thing repeats itself in the next higher octave, where the change from the third register again occurs at F sharp.
Ah, that's the beautiful image, Quan, you were referring to. I see. Okay. So yeah, I think that really gets at the idea of why C256 is selected as the middle C.
Yeah. No, yeah, that's
most accessible to all of the voices, I believe. Yeah, there's a whole book that's been written about this topic. For the time being, we might as well just keep reading.
The register shift of bel canto is a physical property of fundamental lawful significance, not only something regarding voice technique. The register shift is a physical singularity, a non-linear phase change, comparable to the transformation of ice into water or water into vapor. A register shift also takes place in our solar system. It has been recognized for a long time that the inner planets, Mercury, Venus, Earth, and Mars, have many common properties. They are relatively small, have a silicate metallic surface, few moons, and no rings. The outer planets, Jupiter, Saturn, Uranus, and Neptune, have exactly contrary common characteristics. They are large, gaseous, and have many moons and rings. The division between these sharply distinct registers is formed by the asteroid or planetoid belt, a ring-like system of many, many thousands of fragmentary bodies which one suspects come from an exploded planet. So the asteroid belt is like F sharp.
It's the devil's interval, the dissonance. Yeah.
Right. Shall I read the figure 18 in the large distance?
Oh, I see which. Sure.
In a large distance between Mars and Jupiter, there is to be found, which Kepler already had suspected, a relevant orbital region, the asteroid belt. It has a singular character, for it divides our solar system into two fundamentally different arrays of planets, so that we might speak of a register shift. Now it can be shown that the register shift of the solar system also takes place at the F sharp, at the geometric mean of a spiral turn, just as with the soprano voice. If, starting with the outer surface of the Sun, we make a self-similar spiral to the orbit of the innermost planet Mercury, then the continuation of this spiral from Mercury to the intersecting orbits of Neptune and Pluto will travel through one full turn, an octave. The geometric mean of the spiral is reached precisely at the outer limits of the asteroid belt. And it gets even more precise. If we compare the planetary spiral with the spiral of the even-tempered system, where the interval from Mercury to Neptune-Pluto corresponds to the C to C 512 interval, then the orbits of all the planets are intersected exactly at the place where we find the most important notes of the scale. And the asteroid belt occupies precisely the angular position corresponding to the interval F to F sharp. Right, that's more specific.
Yeah. So there we have, you might want to read the description to figures 18b and c, featuring more of our solar system up to Neptune.
From Mercury to the intersecting orbits of Neptune and Pluto, the self-similar spiral carries out one full turn, which here is presented in its projection in two halves.
Right. So from the bottom image, we have the everything from the Sun to Mercury to Venus, Earth, Mars, and then the asteroid belt. And then the other half, we have upwards from the asteroid belt to Jupiter. So asteroid belt is now in the center, and then we have to Jupiter, to Saturn, to Uranus, to Neptune, featuring as a whole one singular turn from beginning to end, or one octave.
Because of the elliptic orbits, we have presented for each planet two concentric circles. The intersections of the spiral with the orbits, projected as presented upon the outer circle of the 12 halftones, hence provide us with a range of frequencies. Now, the asteroid belt occupies exactly the angular position of the register shift for a soprano from F to F sharp. Okay, yeah. Shall I continue? Hence, there exists a perfect harmony between the human voice, the solar system, the musical system, and the synthetic geometry of spiral-formed action upon a cone. Oh, that's awesome. I love it. Such a poet. If the musical tuning is set arbitrarily, say to A equals 440 Hertz, usual today in many places, then this either ruins the soprano voices, or it shifts the register shift to the interval from E to F, instead of from F to F sharp. With that, however, the octave is divided in the wrong place. which destroys the geometry of the musical system and the harmony between music and the laws of the universe. What's his name? The opera singer.
There's many.
Spanish opera singer. The three tenors, the most famous.
Oh, Pavarotti?
No, not that one. The Spanish guy. Domingo. Placido. He agrees. He actually supported and has read the Schiller Institute's brochures on this topic.
Yep.
Yeah.
I think Pavarotti also endorsed the petition to lower the tuning.
Yeah, I'm sure. But yeah, didn't happen.
Mm-hmm.
Is this the right page?
Yeah. Just you're at the last paragraph.
Okay. If the musical tuning is set up, Charlie, right? Yeah. If we should, in this way, wish to arbitrarily alter the tuning of the solar system, it would explode. God does not make mistakes. Our solar system functions very well with its just tuning, which is in exact harmony with the musical tuning of middle C equals 256 Hertz. This is hence the only scientific tuning.
All right. Oops, I just hit stop share. Sorry. Let's do that again. All right, so that was Appendix 10. Vital concepts. Does anybody have any questions or thoughts before we read the chapter 10? Just taking it in?
Yeah.
Yeah.
Letting it root.
Okay, let me just try to find the beginning of chapter 10. I feel like I'm close.
It's also something about the soul. I mean, the pitch of the music, the way it resonates in you.
Mm-hmm.
Having listened to things at a lower pitch, I understand, like the
Lower or higher pitch, or what do you mean?
Well, the pitch that Verdi is asking for is lower than today's pitch.
Oh yeah.
So I don't know if anyone's listened to it on YouTube, but it's out there, and you do notice the difference. If you're kind of like listening to classical music a fair bit, like you will notice like a big significant shift in your understanding of the music and understanding of the intentions of the artist and all those things too, because often it just comes across as like sometimes you have like these periods of chaos in classical composition that, especially at this tuning, it can be quite pitchy and almost sometimes painful, and it shouldn't be. I mean, that's also down to the conductor and the dynamics and the tempos that they use, because they distort music to a certain degree. But yeah.
Mm-hmm.
I'm sure you've listened to Furtwängler, right, Matt?
Sure.
Yeah, like he's like the Beethoven Supremo.
Mm-hmm.
Yeah, I wish we danced to that, because that would be so much more joyful. Because right now I'm panicking. We do Seventh Symphony Beethoven, and it's so fast and pitchy, and it just frightens you, and it's not like with Furtwängler's version.
That's what they're working on right now at the Grand Ballet.
Yeah, we've had it in the rep for ages.
Yeah. And you're saying it's like the music is nice, but the way that they're performing it, the way that they're playing it is too fast and.
Yeah, definitely. Having listened around to different conductors, like we're kind of killing it a bit.
Mm-hmm.
Yeah, because people make the mistake with Beethoven that you have to play it fast, and we're like with dynamics and like bah, 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 bah. And it's like no, that's not what it is. You have to let the silence play on you too, because that's where the dynamic truly is. Like you got to let that fill you, with like suspense and like question and you know, these moments of peace as well. Otherwise, it's all just noise, and it becomes very well a bit. I mean, Beethoven can never be painful. I don't want to say painful. It's just he would find it painful. I'm sure. Sure, he'd listen to it today and be like, "Oh, yeah, what are you doing to my music?" I get angry about that sometimes. I'm like, he's rolling in his grave, people. But God, I could say something, but I'd probably be fired. Yeah. So.
You have a greater vision that you're in this for, so it's okay.
Yeah, it's all good. At least I get
All right.
stuff.
So
Anyway.
my guess is that we can get this done. It's like I said, the heftiest chapter. I wanted us to just go through all this stuff because it is so hefty, and I know it could be discouraging. But keep in mind what LaRouche is about to go through in chapter 10 is really he's creating a space in the mind, expecting an entire university curriculum to be built up around a lot of these concepts. So just by planting the seeds, creating the mental space for the mind to move into the future, you're given sort of guideposts on things to look into, and try to disprove that what he's saying may not be true. Like try to actually work on disproving it. And if along the way you find that what he's saying is true, that investigation will be yours and that knowledge will be yours to then use. So this is, done for that reason. And I don't understand everything. So don't expect yourself to understand everything being said in this chapter, but just keep an open mind and try to get the general broad strokes as best as you can, and stop the reading at any time and ask a question if you need to. But Jerry or Cody, why don't one of you two guys? I know Eureka asked to she wants to just listen in, and that's cool. But why don't you two guys read? And like I said, we'll just stop whenever we need to.
Yeah, I can read if you want. Okay. Chapter 10. Isochronicity, least action, and the Parmenides paradox. We continue the pathway we were traveling in the preceding moments of our dialogue. It is time to bring the intermediate mathematical portions of exploration towards their conclusion. Our proximate objectives at this moment are three types: isochronicity, least action, and the Parmenides paradox. Leibniz emphasized the crucial implications of so-called non-algebraic curvature, the phase of physical space-time curvature associated with such constructions as cycloids, evolutes, and envelopes. For this, see appendices 13 and 4. Non-algebraic curvature became promptly one of the crucial points of irreconcilable difference between Leibniz's circles and the opposing deductionists. The two aspects of this topic most directly relevant in this dialogue on successful survival are the subtopics named respectively isochronicity and negative curvature of physical spacetime. Consider figure 8.
I guess we might want to look at figure 8. Here it is. Gary, you want to read the description of figure 8 there?
Okay, figure 8, least and equal time. This figure illustrates the principle of least action and isochronicity. A sphere rolling down the cycloid from P, with a little mark on it, P prime.
P prime, yeah.
P prime reaches the middle point, O, at the same time as one which is released from P. Even though the curve P prime O is longer than the straight line P prime O, the sphere arrives more quickly at O if it rolls along the curved path, because it is a path of least action.
Yeah, there's some wonderful videos of this as well on YouTube. If you just type in brachistochrone or least action pathways, where it's counterintuitive, right? If you have a marble at point P or at point P prime or at point L, and you let them go at the same time, who would have guessed that they would have all arrived at point O at the exact same moment? Wild, eh?
Mm-hmm.
And then the question becomes, what is the nature of this sort of curvature? Do all curves do that? Or is it the specific species of curve that we see here from L1 to L2 that has this property?
Mm-hmm.
Right? And then if it's a specific species, how do we construct that? I'll leave that as a question, and I'll send out a few videos, one of which will have the answer. So just keep that in mind.
Okay.
Sorry, can you repeat what you said, Matt? At the end there?
The whole thing?
No, just the little part at the end.
Oh, okay. All I said is if this is a specific species of curve, if it's not just any old curve that will have this effect, but a specific type of curve that will have it, then how is that curve constructed, right? The L1 to L2 curve. And then I just said, I'm going to send out a few videos, one of which will have the answer to that question.
Mm-hmm. Cool.
And again, the thing to keep in mind always is, what is the economy of nature? Is there a geometry of nature that we can discover and use to guide our own economy here on the earth and beyond the earth for humankind willfully, right? So our standard is always creation in nature. It's not something arbitrary from a technocrat, right, sitting in an ivory tower telling us what our standard should be for organizing human society.
Mm-hmm. Okay, you want me to go on? All right.
Sure.
L1, L2, that curve L1, L2 is a virtually frictionless rolling track with the curvature of a simple cycloid. O is the lowest point of that track. P is any point on that track other than O, and P prime is any point on the track neither O nor P. P prime O is an alternate, virtually frictionless straight line, inclined plane rolling track. Release two balls to roll freely simultaneously from point P prime. One ball rolling along the arc of the curved track P prime O reaches O before the ball rolling along inclined plane P prime O. Arc PO is a least time track. Release two balls simultaneously, this time at P prime and P respectively. Both will roll freely to O in the same lapsed time. The curvature is, we say, isochronous. In the more superficial treatment of that or analogous examples, it is stressed that the equal times of free rolling between arcs P prime O and PO is a reflection of the factor of acceleration. The truth is directly opposite. It is not the principle of acceleration which determines such a curvature. It is the isochronic curvature characteristic of physical spacetime which is reflected as the phenomenon of acceleration. Imagine a universe defined according to the curvature of the rolling track in this figure. Imagine
I just think that it's such an important idea, because a lot of people would answer if you asked, like, well, why are the planets in ellipses around the sun? And they would say, oh, because of gravity.
Mhm.
And that's as unsatisfying an answer as if you were to ask, well, why do these marbles reach point O at the times that they do? And you got the answer because of acceleration. It's no, you would answer because of least action pathways, because the universe or space-time is organized in least action pathways, would be a much more satisfying answer, which deals with principles, right? Universal principles, not just some mechanical terminology, which is just an effect masquerading as a cause. So it does something very different for the mind, depending on how you choose to think about the problem and think about what causes are underlying the effects that you're seeing. Sorry, I just wanted to point that out.
No, it's a good point. It's like, I think of it that the orbits of the planets were already there before the planets actually occupied those orbits. They were already determined before the planet was there.
Mm-hmm.
Sort of the same idea.
Yeah. Right.
Okay, continuing. Imagine the universe defined according to the curvature of the rolling track in this figure. Imagine all possible functions in a universe of such a physical space-time curvature. Express such functions' effects in respect to point O and all proximate causes for these effects in terms of point P sub 0, P sub 1, P sub 2, etc., alternately. That aspect of such a cause-effect relationship which does not change as we substitute successively points P sub 1, P sub 2, P sub 3, etc. for P sub 0 is the aspect of the cause-effect relationship which intersects us now. Let us term that feature the invariant feature of the process, that aspect of a cause-effect relationship which remains unchanged as we shift the point of reference among the choices P sub 0, P sub 1, P sub 2, etc. In this instant, our attention is focused upon the notion of physical law. A true physical law must satisfy two required standards of invariance. The first is more readily seen in connection to our illustration. The second, more profound, we shall explore later, after but merely identifying it here. Number one, a physical law must be invariant with respect to the processes and positions in which its action is observed. Number two, a physical law properly defined in respect to its bearing upon processes in some part of the universe must be true isochronically at that instant for the altered state of the universe as a whole. As we shall note later on, the latter bears upon the Parmenides paradox, as the treatment of that paradox appears, for example, within Nicholas of Cusa's Didacta Ignorantia. That said, turn now to some other fish to fry and negative curvature. Earlier, we considered one implication of Cusa's maximum-minimum principle, the minimal action required to generate the relatively maximum work, example volume, accomplished. Now, consider the complementary notion, the minimum work required to generate the relatively maximum action. Let us associate the first with the obvious choice of term, positive curvature. Let us associate positive curvature with the term weak forces, and negative curvature with strong forces. Let us examine this array first in light of the Riemann surface function, and then the prospect for constructing the more adequate Riemann-Beltrami surface function. Precede that with a few relevant historical observations. Yes, go ahead.
Yeah, he's also speaking at the time. Mr. LaRouche was working very closely with many plasma physicists and fusion scientists of the day. He had started an organization called the Fusion Energy Foundation, which was a very influential organization looking at different pathways towards accessing and harnessing fusion outside of the standard model approach that was sort of being imposed onto science as a whole for many decades. And a lot of these approaches were cutting edge scientists. Many of them were getting old in this time, but they were making incredible breakthroughs with incredible results experimentally. So the idea of weak forces, strong forces, deal with he's basically trying to help solidify the epistemological foundations of a lot of the good scientists who were very creative, but still were contaminated with much of the Newtonian, Euclidean bad modes of thinking about science and about geometry. So the strong and weak forces are concepts in physics, right, where we're told that we have the four fundamental forces of the thing that holds all the atoms together, which is the strong force, and then the weak force is the thing that causes radioactive decay. It happens very slowly, and it's a weaker force, but it's sort of defined as two separate things. And then you have electromagnetism as another force, and then you have gravity as the fourth force. And they're treated relatively all separate. And what LaRouche is trying to say is that when you look at this real current of science going from Plato and you look at Cusa and Cusa's followers like Da Vinci and Kepler and Leibniz through Gauss and Riemann into the discoveries of the quantum by people like Max Planck and Einstein, there is no separating of these forces, the minds of these people, but these are all aspects of the same higher force, which is more than a force. And it deals more with these qualities of the universe, right? And literally the idea of the mind of God. That's what all of these great scientists are all looking at. They all have a sense that their science, them coming to personally come into communion with the mind of the creator. So it's a much more edifying idea than what we're often being given. Riemann is a guy who, again, is at the apex of this and took this probably the greatest advances than we've yet seen. So just keep that in mind. And the ideas of positive and negative curvature, I don't fully understand how, but he's saying that one form expresses positive curvature would be able to express our idea of weak forces more perfectly, and negative curvature, strong forces. So any questions on those points? I might have been a bit messy how I said that.
Oh, that's good.
Yeah. Okay.
All good.
Okay.
Okay. Appreciation of and controversy respecting non-algebraic curvature is usually dated to the period of Christian Huygens and Gottfried Leibniz's Paris discoveries of the 1670s. See Appendix 8. Not only were both indebted to Blaise Pascal for preliminary work, the physical significance of negative curvature was not only recognized but employed successfully by Filippo Brunelleschi and Leonardo da Vinci 2 centuries and more earlier. Formally,
do we have an example of negative curvature versus positive curvature?
Do we have an example?
Yeah, can anybody think of an example of either case?
Yeah, a dome on a cathedral.
A what? And that's positive or negative curvature?
Negative.
A dome on the cathedral? I guess
On
depends
top.
on what kind of dome you're looking at.
Oh, well, yeah, the dome on top of the cathedral would be positive. I don't like.
Which cathedral? Because there's so many kinds of domes and so many kinds of cathedrals.
Oh, well, the one I'm thinking of is the Duomo in Florence. The
Yeah,
one
more
that
basic. That might have a bit of both in it. Do you have an example of something which is purely positive curvature?
the horizon. The horizon?
The horizon? You mean because it's on the surface of a sphere?
Yeah.
Yeah,
Like when you look at it, it's
a sphere would be a good answer. It's true because it's the surface of a sphere, so that would be a positive curvature. And a negative curvature,
would be.
you can't think of something right now. It's okay. He's going to show us some images, and we'll see one.
I want to try and think. Of,
Why not the saddle on a horse?
Yes, perfect. Horse saddle. Yeah.
Yeah, like caving in,
Okay, yeah.
like inverse. What else? Well, no. Skateboard? No, not really. Not really. Skate park. Skate park.
What's that?
Skate park.
Skate park. Oh,
A ramp.
yeah.
Like
I guess, yeah. Like a what do you call it? Yeah. Skate park would be full of negative.
like a skate ramp. Yeah, that goes
Like
into
if
the
you have
ground.
a half pipe or something.
Yeah, a half pipe. That would be. Yeah, that's better.
Probably, yeah. Okay.
Whoa. A flower.
I think that you're getting the idea, and we need more images of it.
Yeah, we'll probably show better ones than that, I'm sure. But yeah. Oh, but the eye.
The eye, the eyeball.
The eyeball. Yeah.
Well, that's an orb.
But it's no, yeah, it's no, yeah. Yeah, no. When you take it out, it's not. No.
Yeah, it's fun to think about. Definitely, I think saddle. Definitely, really good one.
Yeah.
Also, if you have we had in that bubble video at the beginning, there's some examples where you had like a sheet of soap bubble solution, and it's a sheet, and they took like a pin and they pulled it, and that created a.
So a contact lens.
No, I don't think so.
No, no. Sorry. Okay.
Oh, that's a bit. Actually, yeah. That's a side conversation because I might have a bit of both. Okay.
So yeah.
Okay. Formally, the study of non-algebraic curvatures begins in constructive projective geometry with the most elementary of the cycloids. See Figure 9. This proceeds to the cycloids generated by regular curves, conic sections, other than straight lines. This proceeds through evolutes and into the domain of Leibniz-Monge envelopes. Figure 9, the cycloid. Lay a rolling circle along a straight line, where the circle is initially tangent to the line. Mark a point on the circumference of the circle. Now roll the circle along the line. The cycloid is the locus of the point generated as the circle moves through one rotation. Amateurs, test for yourselves. Is this locus turned upside down isochronic?
Oh, there you go. That's the answer. Again, I'll still send out the video that has the physical construction of these isochronous curves from the cycloid. It's really cool to see a video of these things in action.
Mhm. Construct a figure, the surface of which has everywhere a continuous positive curvature. A figure which represents the largest volume for a curved surface of that area. Put the same task more simply. Rotate a circle, a sphere. Compare this with a pseudosphere, figure 10. With positive curvature, we associate the generation of the greatest work, volume, by the minimum action, surface. With negative curvature, we associate the generation of the relatively largest action, surface, by the minimal work, volume.
All right, so now we have 3 figures, figure 10A, B, and C, which are 3 surfaces of rotation with constant negative curvature, which are all formed by the rotation of different cross-sections of the tractrix. All right, so the first one is the elliptical pseudospherical surface of rotation, which corresponds also to the surface of rotation of the caustic. Right, so that's definitely a lot of negative curvature there. And he's saying it's by rotating certain curves. So if you just look at the side of this, what's he call this? The pseudospherical surface. If you look at the side, you have this sort of rate of change, right? Just as a two-dimensional line with curvature. But if you rotate it around that point, the vertices, and you rotate it 360 degrees, it creates that 3-dimensional image. I forget what the caustic is. Jerry, do you remember what the caustic is?
Not offhand, no.
No, I forget too. Okay. All right, here's the other one.
I did this. This is the parabolic pseudospherical surface, or pseudosphere.
Right, and see we have a different type of curvature on the side of the sphere, that if it was 2 dimensionals and was rotated 360 degrees, it would create this thing that we're looking at. And then the last one is the hyperbolic pseudospherical surface of rotation. All right, let's look at that again. I wonder how they made that one. Anyway, so there's 3 types of negative curvature. Okay.
So let me get this right. Are they saying you're taking an ellipse and rotating it, or taking a hyperbole and rotating it to generate these pseudospheres?
Not.
That's what it looks like.
It looks like that, but I think that at least for the the parabolic pseudosphere. Oh, that might be a parabola. Yeah, you're right. So I guess if you have a parabola for this one, and you rotate that parabola, you get this image.
That's what it looks like.
No, and by virtue of the name as well, I think that must be it. And then it says elliptical pseudosphere, which is caused by the rotation of the caustic. The caustic is something which is related to the tractrix. I remember reading that Da Vinci was investigating, which happened, I think, when you had like a drag weight on a line on a rope being pulled in the water by a boat, and there'd be a certain pathway it would trace out, which would look a little bit like a parabola, but it wouldn't be. And that was called the tractrix. It was related to the caustic somehow. It's been so long since I've looked at this though, so I don't remember.
I remember the caustic. They would show a picture of light being shone through a wine glass.
Oh yeah.
Projection on the flat surface behind it, it would give you a caustic.
People could probably just take note of these words as well and Google them later and just see what pops up.
Mm-hmm.
And that last one is, I guess, a hyperbola. Hard to see where the hyperbola is, though. Anyway.
Yeah, they're all cuts of a cone. You know, the same way you generated the ellipse, cutting the cone, you also can generate a hyperbola and a parabola.
Right.
I haven't done this in 30 years, Matt.
Well,
you're making me think.
It's in your subconscious somewhere.
Yeah. Okay, let me continue.
Right.
Together, they generate negentropy. Generate the relatively greatest work with the minimal action. With that work, generate the greatest surface or action. Look at a Riemann surface function and its problem so. The negentropy of Kepler's universe is defined by the characteristic harmonic ordering of the laws of that universe. A harmonic ordering congruent with the golden section of circular action. By replacing circular action by self-similar spiral action, we generate the Gaussian complex domain as the higher domain, of which Kepler's is a projected image. The formal problem is twofold. Any domain constructed by means of continuous, multiply connected, self-similar spiral action is richly populated with singularities. Indeed, all elementary physical processes can be represented adequately only by functions which are continuously nonlinear functions on this account. This leads us to what is known as Lejeune Dirichlet's principle. Refer in an earlier portion of this dialogue to our reflections upon the subjects of indistinct and distinct forms of singularities. The formal characteristic of continuous impulse of multiply connected self-similar spiral action is to interrupt the appearance of continuousness of that action by means of a harmonically ordered series of singularities. These singularities are in the form of hyperbolic lines or sheets. On a sphere of conformal projection, the discontinuity itself takes the form of what we might regard as a point or perturbing indentation of the sphere's smooth surface. That latter locality interrupts the perfect continuity of movement or action along that surface. Is it a distinct or indistinct singularity? Is the singularity susceptible of intelligible representation within the bounds of the Gaussian complex domain? This question was attacked by Lejeune Dirichlet and Karl Weierstrass. Both showed in broad terms that such boundaries or singularities were implicitly comprehensible from the vantage point of the Gaussian domain itself. By accepting the existence of a relatively higher order of physical spacetime at that point, the singularity persists, but not its property of discontinuity. We bridge the discontinuity in the manner of a Weierstrass function suggests. This is the kernel of what Riemann identified as Dirichlet's principle. Riemann employed that principle to unleash the fuller potential of the Gaussian domain. Hence, we have the Gauss-Riemann domain. The typification of this employment of the Dirichlet principle of topology is the Riemann surface function. See Appendix 9, in figure 11.
Okay, this is all, like I said, very challenging, so we're just getting a broad brushstroke here. So figure 11 is what we see here of a sphere of what looks to be like a torus or a donut, and then a double torus.
A donut. Mm.
You getting hungry, Jerry?
No, I'm just trying to figure out if that's positive or negative curvature.
Seems like it's a bit of both, right?
Yeah. I would think it would be negative curvature.
Negative on the inside and I guess positive on the outside?
Yeah. Yeah, interesting.
Yeah. I guess it's worth reading the
Figure 11, the Riemann surface function applied to structures in space. The topological projection of a circle, constant positive curvature, is simply connected. There are no singularities, holes, nor poles. The projection of a torus with its hole in the middle is triply connected, and the projection of the third form, pretzel shape, with two holes is fivefold connected. LaRouche cites Beltrami's work to offer the hypothesis that these singularities are not simply points or holes, empty space, in an otherwise continuous positive curvature, but rather regions whose physical geometry is characterized by negative curvature.
Hmm.
All right.
big idea is a lot of future work to be done on that. I know one thing that I saw that was interesting in some of these science videos online is they have things like very slow motion picture filming of like a propeller in water, which is releasing kind of like a cylindrical spiral bubbles, which move in that sort of cylindrical spiral way through the water, which you'd otherwise not see in such beautiful geometries. And you have things like toruses as well being formed, like dolphins do it in nature, right? They blow toruses and they just play with them as bubbles. And when you have like a bubble, there's a certain way, if it's moving in a certain geometry and speed, you can touch it in the middle and it'll create like a torus. So there's just these interesting geometries that happen in liquids and also in plasmas too, which I guess we'd be able to make better breakthroughs if we were plasma scientists trying to discover fusion or just trying to map out the nature of reality if we had these concepts in our mind. But you got to keep in mind that they're not really taught in most universities. People are given maybe some formulas with Riemann's name or Kepler's name, but the actual discoveries that Riemann or Dirichlet or Gauss made or Kepler, people are not allowed to learn or read their original writings to discover for themselves what those are. So they're not able to really think about how these people were thinking, which would allow them to make better breakthroughs and better understand the nature of the universe that they were dealing with. So it's good just to keep that in mind. There's a suppression of a lot of the things we're reading about here. Okay, that was just my 2 cents. But you want to keep reading or any?
Okay. It is the method of Riemann that whenever the representation of a physical process encounters such a singularity, he says, in effect, quote, if the process continues through and beyond this point of apparent interruption, it will do so in the form the Riemann surface function suggests. A useful illustration of such a tactic is the case of the 1859 dissertation on the properties of plane air waves of finite magnitude. This is already clear implicitly in his 1854 inaugural dissertation on the hypotheses which underline geometry. Riemann understood this, his optimistic method, as premised upon the demonstration that a Kepler, Leibniz, Gauss, Riemann universe is characteristically negentropic. His posthumously published notes on Herbart Göttingen's lectures attest to that. So the tactic associated with the Riemann surface function is based on asserting that if continuity is affected through and past a certain singularity, this continuity will assume a foreseeable form. With this qualification, this process is expressed in terms of functions of positive curvature before and after the generation of the relevant singularity. However, the hyperbolic singularity itself expresses a negative curvature. The development of the transonic shock front in Riemann's referenced 1859 paper illustrates the appearance of the negative curvature.
Mm.
Short,
Yeah.
in the case,
Go on.
You were going to say something?
No, I'll shut up. Just keep reading.
Okay. In short, in the case that the singularity ceases to be a discontinuity in the appropriate function, the following result may be expressed in terms of reference to positive curvature. Riemann does not address the negative curvature functionally. He limits himself to showing the form accepted by a solution to the problem, but not the explicit functional solution itself.
Okay, yeah, I guess the thing, just for those who may not know, that when Riemann, I think he said he wrote these things in 1859, he forecast by about 20 years the sound barrier, supersonic, what the supersonic sound barrier would be. And a lot of people are very mystified how he was able to foresee what that would be and what it would look like and where it would be. But LaRouche is sort of speaking in such a way because he wants people to get into Riemann's mind, to understand how he was thinking about the nature of the space, such that he could say that at this point, through this means, this is how the sound barrier will break. And he was looking at shock waves. Similar things that Da Vinci was looking at. If you look at Da Vinci's notebooks, he's looking at what point do waves on the water that I'm observing grow and all of a sudden stop acting like their character changes from being sort of just a curve to being the sort of tidal wave we see coming at you with a tsunami, or on a stormy day on the beach, where you have a different type of wave moving towards you. So there's a break where the species of the wave changes. So these boundary conditions exist, and it happens as well in the more invisible fluid of gas, which is the air. Has a lot of similarities to water, but some differences too. But Riemann was able to think in those terms and make those forecasts. So that's there.
Mm-hmm. Okay. A truly adequate solution is sought. When, for example, is a solution proffered by Riemann's method the result which must occur of necessity? It is not sufficient to note and to react to the fact that the generation of a singularity requires a solution of that form. Possibility is not sufficient. Does the existence of the singularity cause such a solution to be generated? We must examine the singularity itself more closely. That singularity is no indistinct form of boundary, no mere point, no mere logical abyss in the form of a whole. The way by root of which this singularity is generated by the continuing impulse of multiply connected self-similar spiral action causes the singularity to be hyperbolic or hyperboloid. and to have a characteristic negative curvature of this kind. Eugenio Beltrami showed how this must appear as a region of singularity in a Riemann surface. Figure 12A to C.
Ah. Okay, so there's three images. The one on the bottom is the Beltrami model that he made. And Beltrami was a collaborator of Riemann. A lot of his insights also gave birth to modern aerodynamics. A lot of the engineers from the 1930s and 40s and 50s were doing all of the pioneering work on jets that could travel faster than the speed of sound, including those in Canada who were working on the Avro Aero. We're looking at Beltrami's work. But anyway, that's Beltrami's torus there. And what we have is, I guess he's going to describe this probably. Ah, yes. Okay, figure 12 has a description.
Okay, figure 12, the generation of a singularity in a Riemann surface. A, high-speed photograph of the implosion of a liquid irradiated with ultrasound. B, the drawing shows the process of change of form and the shrinking during implosion. C, Beltrami's model resembles the photo A.
Right. So, okay. So that's a split-second image of a collapse of what is it, a bubble? Or a liquid irradiated with ultrasound. Okay. So it doesn't just blow up chaotically. It at a certain point, that liquid is no longer a simple, spherical sort of image or shape. All of a sudden, it takes on this toroidal. It has a collapse in the middle with a negative curvature on the inside, like a torus, and that's a cross section, I guess, describing it, of the different states of that of the collapse of the liquid. So why is it happening the way it is and not some other way, right? Why doesn't it just like blow up, or why isn't it just chaotically melting down? Why does it happen that way? What does that say about the universe? Or the sorts of questions a scientist would who's worthy of the name would have in their mind. Oh, I'm sorry. That's still in italics. That's still more of the description. I'm sorry.
Yep. Characteristic is the indented, negatively curved surface. These ultrasonic experiments may represent more than a simple analogy to Beltrami negative curvature space. Recent observations have shown that such ultrasonic experiments lead to the generation of light, sonoluminescence, with the greatest amplification process seen in nature, and with extremely coherent outputs. I think that's a magazine, Nature, volume 352.
Yeah, you don't have to read all the citations.
Okay. Others have indicated that the process leading to the light emission may involve spherical Beltrami vortices. Okay. All right. Consider the negentropy of Kepler's universe. Note that this negentropy is characteristic of the Gauss-Riemann complex domain as a whole. This invariance of the two regimes is associated with the golden section and its harmonies as the metrical characteristic of self-similar spiral action. Similarly, it is the harmonic ordering of the generation of hyperbolic singularities by continuous impulse of multiply connected self-similar spiral action, which expresses the characteristic negentropy of the Gauss-Riemann and Gauss-Riemann-Beltrami complex domain. That latter characteristic is the harmonic ordering of increase of accumulated density of singularities per interval of cycloid action. That characteristic is implicitly the measure of increase of technology, and of potential population density.
Yeah, so on that note, anybody who hasn't watched the Power of Labor 2-hour documentary video from 1984, definitely should watch that by next week, because a lot of these concepts are also elaborated upon, especially what he just said in the past few paragraphs relating the geometries of cyclic action with technological increase and potential population density increase, and how all of that relates to energy and energy policy. That's really elaborated nicely in that video.
All right, you want me to continue?
Mm-hmm.
Yet, those various measures of negentropy define processes which are bounded by negentropy without representing the negentropy itself. Once we shift our focus to the causal sequence of alternating weak and strong forces, the intelligibility of negentropy becomes a distinct geometrical idea. The negentropic process is then represented intelligibly as a self-bounded process. This, all taken together, defines a different set of ideas about measurement and substance than those in common use in either the classroom or ordinary conversation. With these changes, Nicholas of Cusa and Leibniz would, and implicitly did agree. Implicitly, Plato would have followed our argument, would have understood and agreed. If we do not recognize such agreement, we understand nothing essential respecting the purpose and content of Plato's dialogues. A few reminders. Metrical ideas feature inclusively. 1. Circular action, isoperimetric action. A. Constant rate of continuous circular action. B. Counting in cycles. 2. Sections of circular action. A. Golden section, negentropic harmonics, curvature. B. Entropic harmonics. C. Invariance of negentropy in projective correspondence of golden section and self-similar spiral action. 3. Negentropy. A. Increase of density of singularities per interval of action. B. Alternating weak and strong forces. 4. Isochronicity. Substance. Physical spacetime has essentially universally negentropic but subsuming entropy in the guise of negative negentropy. Efficient cause is substance. Substance is efficient cause.
So those are the key concepts students should hopefully be induced to struggle with and come out of this whole process with as concepts. Not easy, but simple.
We'll struggle with that.
Yeah, things we should be struggling on for a long time, and that's okay.
Mm-hmm.
So 10 o'clock on the dot. That was pretty good.
Oh, okay.
Those are some very big
Good
ideas.
ending, then.
Any thoughts or questions or anything?
Just that
Well, I
idea
would
of
like to make a
weak and strong forces, I don't get.
I don't understand how he's relating to positive and negative curvature, but I think the general idea is that standard model cosmology wants us to assume that strong and weak forces are pretty much have very different characteristics. They're not united very organically, but they're both two sides of like the nuclear process, right? Like one is what holds the electrons or all of the protons together right inside the nucleus, as is commonly assumed. Because you think like, well, how do all of these protons in a nucleus stay so close together? When if you bring like a magnet with a positive force and another magnet with a positive together, if they're strong magnets, you can't get them to get close to each other. It repels as close as they get. So how could all of these common same forces that should be repelling stay packed in so closely, tightly together? And they just say, oh, strong force. And
Oh, now yeah.
yeah, and then like, you know, these different atoms are decaying slowly. You know, they're losing their electrons, they're losing their neutrons slowly, and they're transmutating to become something else over time, slowly, some fast. And what causes that to happen? Why does that occur? And they just say, oh, that's a weak nuclear force. But again, why are we assuming that there are these two different things? Why are not two parts of the same thing? You know, maybe there's something else happening that describes both of them.
He's like in a cave within his book.
Yeah.
He's almost eaten.
What's that, Julia?
She's like, the way it looks now is like you're in a cave because the camera on you is like a lens.
Oh, yeah.
Yeah. Like the room is even bending.
Right.
Yeah.
Positive curvature there.
Yeah. That was her example of it.
That's good.
She didn't realize we weren't on mute, and she's just expressed that to all of you.
No, that's a good thought.
It's
Cool.
like, yeah, I see it.
Was that
Yes.
Kwan you were saying?
Yes, but I think that let's not forget that one of the element of the title of this chapter is the Parmenides paradox.
Mm.
And I think that precisely he wants to develop an answer to that Parmenides paradox. Because if you remember, Parmenides said that there is only being and there is no change, okay?
Mm-hmm.
And Heraclitus said that there is only change. And what would Plato reconcile the two propositions? Plato said that at the level of cassia of senses perception, you have only changes. In that sense, he agreed with Heraclitus. And at the level of eidos, of true reason with a capital R,
Mm-hmm.
you only have being.
Yeah.
Okay, so when LaRouche said that, uh, I consider that what LaRouche explained is that chapter is his way to answer to Parmenides' paradox, and his way to express in his own words the four levels of Plato epistemology, okay? Because once again, for Plato epistemology, you have the four levels. You have the levels of the shadows, the acacia, and you have the levels of pistis, which is conventional truth, that he called doxa, opinion, okay? And when you were speaking of the nuclear forces and you were speaking of strong forces or weak forces, you are at the level of doxa. And the other two levels, which is episteme, science, the level 3 is precisely dianoia, meaning mathematical constructions or mathematical notions. So when LaRouche is speaking of the negative curvature or positive curvature, for me, it's at the level 3 of Plato, dianoia. And the last level, eidos, is precisely to be capable, as though those extraordinary scientists, to be in God's mind, okay? Because what is God's mind after all? It's those fundamental forms, eidos in Greek or ideas in English, that are at the foundation of the universe. And I think that the last paragraph is extraordinary because he said that, I'm sorry, I'm moving the pages. Blah, blah. That, blah.
Efficient cause is substance, and substance is efficient cause.
Exactly. Substance, physical space-time as essentially universally negentropic, but subsuming entropy in the guise of negative negentropy. Efficient cause is substance, and substance the efficient cause. Okay, because if you remember the principle of maximum minimum of Nicolas de Cousin, okay, associated with the positive curvature, if I remember, is the maximum, the minimum action to cause the maximum effect, and associated with negative curvature is the correlation of that proposition, okay? And in the text of LaRouche, he said that two are intimately together, and as you said, in an organic fashion, okay? And I know that's what I would say. It's my Chinese side speaking, but if you remember the image of the yin and the yang, okay, you have the circle, you have the white fish, and you have the black fish. Well, it's exactly like that. It's the, you have the, let's say the white fish is the positive curvature, and the black fish is the negative curvature. And when he said that uh, physical space-time essentially universally negentropic, and but subsuming entropy in the guise of negative negentropy, meaning that the circle would reconcile the two together, but in an organic fashion. Okay, and that would be the level 4 of Plato epistemology, eidos, or maybe in a little bit grandiose way of speaking, reading into God's mind.
Wonderful. Wonderful. You know, I always miss that point you just brought up. And I don't think it's a coincidence that just like in the Parmenides dialogue, it's all about what's not there that gives you the answer to what Plato wants you to think about, because he's bringing up all of these problems and paradoxes, right, on the nature of reality and change and no change. And he's really like, it's he's having fun with it in many ways, but he never gives you the answer. And it's probably no coincidence that in the course of this big chapter with Parmenides paradox in the title, he never brings up Parmenides. But that's the key. It's
exactly
what he's not saying that is giving you the solution.
Exactly. Exactly, because all the chapter is an elaboration on the Parmenides paradox.
Right.
According to his own words, of course.
Yeah. Helping out. That's good. That's really good. Huh.
And I would like to add that the Parmenides paradox is all philosophy, because everything in philosophy is about being and phenomenon. Being and phenomena, one and the multiple phenomenal realities.
Like knowing, unknowing.
Yes, but in French, I would say l'un le multiple, meaning the foundation and the multiple phenomenal realities from the foundation. And
Right.
once again, that's why the last sentences is extraordinary. Okay, uh, uh, substances is effective cause. Yes, efficient cause is substance, and substance is efficient cause, meaning that you don't have to look for small details. The architecture of the universe reflects God's mind or God's forms, ideas, and that architecture is sufficient by itself to be and to manifest. And the work of the philosopher, and I use the word philosopher in a very big way, okay, meaning people going to the search of the truth. The work of the philosophers is precisely to transcend acacia, the shadows, to transcend pistis, the conventional truth, and even to transcend dianoia, because the mathematical objects are only uh, a stepping point to the ideas, to the idols, to the forms,
Mhm.
to God's mind. If we truly believe that we have a capax Dei, or if we truly believe that we are imago Dei, for example.
Mhm.
Mhm.
Yeah. And that was what Einstein described his motive to be when he said, "Why do I do science?" And it's to discover the mind of God and nothing less. And you'll
Exactly.
those types
To
of
be
comments are visible in the words of Max Planck, in Kepler, in Leibniz. They're all communicating the same motive, and it bears fruit, right? It's like you could say, "Oh, that's just their religious theology," but they're good. They're kooky religious fundamentalists or something, is how many people brush them off, and they say that's their choice. But I like their science. But it's like the reason why their science is so good and so revolutionary might have something very, very much connected to their theological foundations. It's not two separate things.
yes,
Mhm. Yeah.
yes, but I think that unhappily we make the distinction between theology and philosophy. I think that there's distinction between the two, because I would like to remember that I'm sorry, that the three supreme form, the three supreme ideas, the three supreme idos, by increasing order, beauty, goodness, and truth, right?
Mm.
So uh, the beauty, mathematical concepts or notions of music, of instruments, or music of the sphere is beauty. But that beauty is a reflection of something good, because inherently organic. And because it is inherently organic, efficient cause is substance, and substance is efficient cause. It is simply the manifestation of something foundational, which is truth. So it's together.
Hmm.
And I think it's the true, I don't want to offend anyone with religious belief in a more traditional sense, but I think that beauty, goodness, and truth is the true Trinity.
Hmm. You make a good philosopher, Kwan.
Yeah.
A
My
little bit.
yeah.
I
Thank
have
you.
my good, I have my good moments.
It was beautifully put. I really enjoyed that. I was just thinking we about this tonal action, and we have a step in ballet called the pirouette, where we turn, and I'm thinking that it's probably based off of this, like in the human body, because well, it's hard to explain, um, but like we have dancers that can do, like, I'm not saying myself, but we have dancers that can do like 14 rotations on one foot with their other foot placed on their knee in sort of a channel 4, like a number 4 position, if that explains well. So your leg is bent, like at your knee there is a direct right angle where your foot points towards your standing leg, and you create like the number 4 with your 2 legs, and then and then we turn. And I think this architecture has been derived from this understanding of the conal structure in the golden section as well, because it's ballet is formed in the Renaissance. So I'm thinking that a lot of the positions that are coming, and something that I should do a lot more research into, is coming from this.
I think that there's definitely
Because when
anybody to make a breakthrough in this topic, Nick, it's you.
yeah, I really need to focus on it, because like also when we do double tour in the air, which is a jump, and you have 2 turns, full rotations in the air, so it's a 720-degree turn, and you land on the same spot. And when we're taught it in school, they're always telling us about the internal spiral that you have to imagine as you go up, and you have an internal centralizing spiral going on inside of you, which is almost keeping you centered and not having you fly out to other directions, which makes me think of the planets and how they're kept in a kind of constant, conal action, much like the human body can be if you apply aesthetic design to it, and then you apply that technique over a period of time till you perfect it to the point that you can do that action. So yeah, I mean, there's loads of videos on the internet where you can see these things, and you'll see what I'm talking about. Also, ice skaters do it. Figure skating, when they do in the axle, triple axle, it's called.
Yeah.
So they are in an arabesque where their leg is in a right angle to their body. So they have one leg, and the one leg is horizontal to their vertical body, which creates like a T, a T bent over, like on its side. And then they use that back leg to bring momentum into, again, a rotational, like a conal action, a spiral action taking place. Just the only difference is it's traveling for them. That spiral action is moving like a whirlwind,
right?
Like a tornado.
Yeah, no, that's an important idea, I think. Yeah, the visualization of the perfect spiral to help guide your development as you're practicing. Yeah, very good. I mean, same thing too when singing as well. Like for good singing instructors encourage you to visualize the sound, the music that they're trying to make, and work really on visualizing that in its ideal sense as a guide for you to organize your own development towards. So, yeah.
Because Lynn's saying it's in the human voice, but is it not also in the human body itself? Like
it's everywhere.
Yeah, it's everywhere. Yeah, because you see in the Verugian man.
Yeah. And I would like to add one last thing. Okay, do you know the statue called Nataraja?
No.
No.
He's frozen.
No.
Is it you?
Okay. I don't know if you. Yes, I said that I would like to add one last thing. Do you know the statue called Nataraja?
No.
No.
Okay. Nataraja is Sanskrit for the Lord of the dance, and or the king of the dance, if you want.
Ooh.
And that statue is exactly the aesthetic representation of everything we discussed tonight. Okay, because at the center of that, you have a beautiful young man. Okay, and that beautiful young man represents pure consciousness, and around him you have
You mean Shiva?
Yes,
Yes.
most of the time that beautiful young man is identified as the god Shiva. You're right.
Okay.
And around that, the king of the dance, because Nata and ATA means dance, and Raja, of course, is king, like in Maharaja, for example. So the king of the dance is pure consciousness. And around the beautiful young man, you have a circle of flames. And that circle of flames represent phenomenal reality. Okay? So that circle of flame is the exterior manifestation, precisely in understanding, of the dance between negative curvature and positive curvature. And at the center is the mind of God, or if you want, pure consciousness.
This is a Vedic, this comes from like the Upanishads?
Yes. Yes, it's come from Upanishad. It's and you just Google Nataraja and you will see many beautiful statues
on
that topic.
That one.
Yeah,
Yeah.
exactly. Yes,
Cool.
exactly.
So actually, he has two kinds of dances, like the Lasya, which is the creation dance, and the Tandava, the destruction dance.
Exactly.
And it says
And I
his,
think that
his cosmic dance destroys a weary universe to make way for creation and rebirth.
exact. And I would pretend that at the center you have pure consciousness, but you also have the three primordial ideas or forms, which are beauty, goodness, and truth. And Shiva, as you know, as you maybe know, Shiva means good or goodness. And you have the beautiful statue. So you have the three concepts of beauty, goodness by the name of Shiva, and truth represented at the center. And the surrounding flames is the dance of negative curvature and positive curvature, expressing the organic architecture of God's mind.
Is there a elaborated philosophy that you'd recommend that develops this a little bit more from, because I haven't looked
Uh,
into the
uh,
Indian philosophies very much.
yeah, but I mean that you have six major branches of Indian philosophy,
Hmm.
and that statue for me is the aesthetic representation of
Hmm.
all the six branches of everything that
Wow.
Indian philosophy produced since the last 5,000 years.
You should write something on that, Quan. We would
Yeah.
absolutely publish that.
Oh my God, that'd be amazing.
Yeah, why not? Or maybe I would make some comments on that in our next meetings, because I'm more of a speaking guy than a writing guy.
But you write well still. Keep that in mind. Okay, cool. Oh, it's always a pleasure. Guys, this is really good. I'm really happy we got through this. And just to keep in mind, the next chapters, this is, I think, the most challenging chapter that we're going to be dealing with for a while. At least for this book, which is almost finished. But the remaining three chapters are on human morality, followed by the individual and society, chapter 12. And then it ends this small book with chapter 13 on agape. So that will end out the this particular reading cycle for In Defense of Common Sense. So I think by next reading session we should be able to finish this book. But really, it's such a marvelous piece of work that, like I've said, we're just going to keep. You can keep going back to this throughout your life, and there's constant rich philosophical fruit to be picked off of almost every second page. And these appendices are really, really gorgeous too. So keep a notebook going. Every time you read something, I know for me, new thoughts, new questions emerge, and writing them down helps a lot. It helps also organize my research pathways, how I choose to use my time, because that's something we squander a little bit too easily sometimes. So this notebook helps enormously, and reading with a purpose always. The idea also of thinking about article topics, class topics as you're writing, keep those things in mind, because there's always opportunities with the Rising Tide Foundation and just, personal blogging, things like that. It really helps organize your thoughts and mature ideas, which just reading for consumption's sake doesn't do. So next week we'll continue this on. We'll finish it up, and then I would propose some Max Planck, who wrote some wonderful essays on the philosophy of physics, which could follow this up quite nicely, or some Helen Keller. We'll see. We'll keep a dialogue going on that.
Yeah, we never finished that fine Helen Keller that we started.
Also some Tagore, like I was just looking at some of Tagore's On the Religion of Man lectures from 1930, Rabindranath Tagore. Fantastic stuff.
Yeah.
It's right up, it's so in harmony with everything we've been looking at.
Right.
So we might fold that into some of this as well.
Ooh, sweet.
Oh, Catch you this Sunday. We probably won't do a lecture. We'll take a little break this particular Sunday, so we'll just meet back. We'll read on Wednesday, and then we'll get back on the lecture cycle the Sunday following. Okay.
Great. Cool.
Okay. Bye, guys.
Thanks, Matt. Thanks, everyone.
Ciao.
Okay, ciao.